Number 3 is comparing two different elements. We are comparing oxygen and nitrogen here. And according to this is the 1s2 of nitrogen, and this is the 1s2 of oxygen, because that's what it says here. We're just looking at the 1s2. And we're trying to figure out why there is a difference between them. So let's find big and small. So this guy is big and this guy is small, and this guy is big and this guy is small. And so what it tells you is that oxygen is a bigger number than nitrogen, which is a smaller number. So what they're doing is they are trying to get you to understand that oxygen is harder to remove the electrons here than nitrogen is. And then they want to know why. So in part A, the student says that shielding is responsible. Well, what do you think? Does that make sense when you compare nitrogen and oxygen? Well, let's find them on the periodic table. Here they are. They are right next to each other on the periodic table. So does it make sense that shielding is responsible for the differences seen? And the answer is no. In order for there to be a difference in shielding, they have to be at different vertical levels. So for instance, instead of comparing nitrogen and oxygen, if we were to compare nitrogen and phosphorus or arsenic, those would have different shielding because they are at different energy levels. Nitrogen is at energy level 2, phosphorus is at energy level 3, arsenic is at energy level 4. But if we compare nitrogen and oxygen, they are right next to each other on the periodic table, so they will have the same amount of shielding. In fact, here are their electron configurations, and you can see that for nitrogen here, we have one level, and then its valence level is out here. So this is its valence that's out here. So there's only one level of shielding inside for nitrogen. And in oxygen, you see the same thing. You've got the one level that's here, and then you've got the valence that are out here. These are your valence. And so consequently, oxygen has a very similar amount of shielding as nitrogen does, because they are both at the second energy level. So the answer to part A is no. Shielding does not account for the differences seen because both of them are at the same energy level. Both of them are only being shielded by those guys. Plus, not to mention the fact that in both of these cases, this peak that we're looking at here is the 1s2 peak. So in each of these cases, the peak is talking about this inner shell that's here. This inner shell. And if we're talking about the inner shell, then there is no shielding between the nucleus and the inner shell. So again, either way you look at it, shielding cannot be used to justify the differences that are seen here. Well then, what can? Why can we see a difference between nitrogen and oxygen? Well, let's look at part B. Part B says a student claims that nuclear charge is responsible for the differences seen. What do you think? Well, let's take a look at nitrogen here. In nitrogen, there are 7 protons. So this nucleus is kicking off 7 positive charges worth of nuclear charge. And in oxygen, we have 8 protons. So in oxygen, we are kicking off 8 positive positivity worth of charge. Remember, in Coulomb's law, as charge goes up, your energy also goes up. So yeah, so because these guys have similar amounts of shielding, and we're talking about the inner 1s2 electrons anyway, so it doesn't matter. Because these guys have similar amounts of shielding, but oxygen has more protons, it is totally justifiable then that this guy is going to have more energy because he has 8 protons versus this guy here who has less because he only has 7 protons. So that one can absolutely